Okay. So today we're talking about solids and their cross sections. So we need to remind you of some shapes that you learned probably definitely in 7th or 8th grade. So a prism is a solid. So I would underline the word prism. A prism is a solid that has two congruent faces. They're called bases. This is the key. Two congruent bases. So if I were to look at this shape right here, this is a rectangular prism. This could be my base, and this could be my base. If I were to look at this shape right here, what are my bases, Riley? What are the bases of the shape that I just drew?
The right triangle.
Yeah, the bases are these right triangles. It's sitting on its side because these parallelograms or rectangles are not congruent. You don't have any information about them, but the bases are congruent, okay? So we know that prisms have faces, and those faces are parallelograms. If they're right prisms, they are rectangles, okay? So the first question A says, why do you believe these are called right prisms? Well, we know that a right angle makes a 90 degree. These are called right prisms because the faces are perpendicular to the bases. The faces are perpendicular to the bases. Does that make sense? So the faces are perpendicular to the bases. That's why we call it that. And also, all of the faces are rectangles. So if it's a right prism, the faces are going to be rectangles. If it's an oblique prism, the faces are going to be parallelograms. And I'm going to draw an oblique prism because I think that that's super helpful. So here is my base. Let's see, I don't think I can draw it that way. I mean, I know it can be drawn that way, but my brain can't process it that way. Let me do it like this first. So I want you to imagine that someone took a Kleenex box. Is there a Kleenex box anywhere close? Will you throw that Kleenex box to me really fast? So this is a right rectangular prism. These two things could be the bases, or these two things could be the bases, or these two. It doesn't really matter because it's a rectangular prism. Because the top and the bottom are congruent, side congruent, back, front congruent. So any of these could be bases, but you have bases and then the rest are faces, which are rectangles. And notice that the face is perpendicular to the base. Now, if I took this Kleenex box and imagine that I like sat on it and shrunk it, not shrunk it, but like took it like this and went like this. It means that it like was kind of tilted. So oblique means that they're slanted. So that's why your faces would be parallelograms. Oblique means that they're slanted. I almost killed myself there. Okay. So if you sliced a prism, think about cutting into like a block of cheese. If you sliced a prism and it was horizontal through the base, like you sliced it horizontally, the plane is horizontal to the base. What do you think you would see? Well, you would see a congruent face. And it's going to be the face would be congruent to the base. Like if I were just to cut this in half, perfectly horizontal, like so parallel to the base. Horizontal means parallel to the base. Parallel to the base. If I were to cut through that, this face or this new cross section, it's going to be congruent to its base, right? So the cross section is congruent to the base. if I sliced a prism vertically, so look at this shape right here. Let's change that color so it shows up a little bit better. If I slice this triangular prism vertically, what shape am I going to get? Do you see that shape inside of there? This is a triangular prism, but this face on the inside is a parallelogram. It's a parallelogram. The cross section is a parallelogram. It's bad because it's hard to see what I'm shading in, I think, with all the colors like from the board, but okay. A cylinder is much like a prism, except that the definition of a prism was that you had two congruent bases that were polygons and the faces were parallelograms. Well, first of all, this is not a polygon. Circles are not polygons. Polygons are closed shapes that have vertices, right? There's no vertice on a circle. So a circle is really not a polygon. But also the faces that surround my cylinder are not, these are not nice square, like rectangular or parallelogram faces. Okay. So why is it called a right cylinder? Again, because the sides are perpendicular to the base. But this cylinder right here, it's saying what two measurements from this cylinder determine the measurements. So what two things can I alter that will change the measurements of the cylinder? Well, one, I can change the what? The radius. And number two, I can change that's H, height. So the height or the radius, control the size. And it might have a diameter drawn, but when you think about volume, we use radius. But you could put radius / diameter, something like that. Yeah, so the height of the cylinder and the radius, the height and the radius determine the measurements, right? What two-dimensional shape wraps itself around a cylinder? Let's look at the coffee canister. Perfect. So what shape actually is wrapped around a cylinder? Well, would everyone agree that this is a cylinder? Yes? Okay. If I were to take this piece of paper, what kind of paper is this? What's its shape? What did you say? Yeah, it's a rectangle. I thought you said it's white. I was like, well, yeah, it's big paper. Okay, yeah, this is a rectangle. And look what happens. It wraps around. Now, it's not long enough to fit around this, but you get the idea, right? So what shape is wrapped around, what two-dimensional shape is wrapped around a cylinder? A rectangle. Oh, I know, that's so crazy. So let's talk about what those dimensions are. So if I'm talking about the dimensions of a rectangle, Here's my rectangle. Well, if this is the length and this is the width, the length actually represents the height of the cylinder. Can someone get the door, please? And what is the width?
Sorry, I was trying to find the servant.
She's not here today.
Oh, okay.
Okay. And the width, it's not the radius. It's all the way around the circle. What's that measurement? No. Diameter goes through the center. What's that measurement all the way around? Circumference. The width is the circumference of the circle, which is the base. Okay. So I'm going to erase my drawings on my radius for a second, because question C says, hey, what shape could you put inside of a rectangle, or what shape could you put inside of your, like what shape, if you rotated it about one of its sides, would make a cylinder? So here's what I'm going to do. I'm going to drop, I just want you to think like of this as a y-axis. Think of this as like an XY axis, where this is the place where it comes through the cylinder. So I'm going to dash it right here because it's going through. And then this is also going out the bottom, right? What shape could I rotate about the y-axis? Yeah, that as I spin it, right, makes a cylinder. It's a rectangle. Are any of you guys in computer aided drafting? Did any of you guys do like, yeah, Project Lead the Way. Probably Mr. Helm has you guys using like some computer aided drafting, right? That's how that stuff is created. Like cylinders and all of those shapes that you create are actually an XY axis, XYZ, honestly, an XYZ axis. And you're just rotating those shapes. That's how those are made. Okay. So what shape could you take and rotate about its side? You could take a rectangle and rotate it. Okay. Does that make sense? Is that good with you guys? Does it not make sense? Okay. Here's a good visual. If you just took a piece of paper and wrapped it around your pencil like this. Look at this. If I just took a Post-it note, because they stick, and I just went like this really fast, what shape do you see?
Flag.
You see a flag this way, but do you not see how it, like as I spiral it, it becomes a what? A cylinder, right?
Not a circle.
Yeah, circle with a piece of purple Post-it on it. You're exactly right. All right. The next solid that we're going to talk about is a pyramid. Pyramids are different than prisms or cylinders because why? Has one base. Yeah, we have one base. It's always going to be a polygon, meaning like a square, a rectangle. You could have a hexagon. You could have a million different polygons, any kind of polygon that you can think of, right? But the cool thing about it is pyramids, all of the other faces are, what's that shape right there? Yeah, triangles. All of the other faces are triangles, and they meet at a common vertex. They meet at a common vertex. That vertex is typically called the apex. It's like the highest point, right? So this is your common vertex. So this is my base, or this is my base. This is a pentagonal pyramid right here. The one on the right is a pentagon. This one is just a rectangular pyramid. And notice that the faces are all triangles. The faces are all triangles. So tell me why, if I made a cut that was horizontal through the plane, or remember we said parallel to the base. If I cut horizontally, it was parallel to the base. Tell me why the shape that I get right here is not congruent to my base. Why is it not the same shape?
Because you have a square pyramid, and then what is that? A pentagon?
Yeah, I'm just talking about this. You can just use this one right here. This is a rectangular or square pyramid. Why is this yellow box not the same as the green one on the bottom?
Farther up you go, the smaller it gets.
Thank you. The farther up you go.
What's so funny? Would you like to share with class?
The smaller. I don't know why it's not letting me write. Smaller the shape is. So then the second question says, but what kind of relationship does the base have with this cross-section shape? They're not congruent to each other, but they're what? Yeah, but I want to compare these two shapes. What can you tell me about this shape compared to this shape? They're not congruent, but they are, what'd you say? Yeah, they're similar. They're similar. Now I'm going to do something that's maybe going to just make your brain hurt, but it shouldn't. What if I told you that, hang on a second. What if I told you that these measurements down here were 4 and 6? And then I told you that, just hang on a second. Then I told you that this measurement right here was 3 and this measurement right here was 2. Well, from the base measurements, my length and my width are in the proportion of 6 to 4. So you could write it like this, or you could write it as a fraction. And then the cross section, I just want you guys to understand this, is in a proportion of 3 to 2, or 3 over 2. What do you notice about these two fractions?
They're
Well, if I took the measurement 6 and divided it by 2, and I took the measurement 4 and divided by 2, what would I get?
2 and 3.
I would get 3 over 2. They're proportional, right? They're similar. That's what that means. It means that they have the same similarity ratio. Okay? Under what conditions would the triangular sides of the pyramid have all congruent face, like would all of the faces be congruent? So under what condition? What has to happen to the, like, something has to happen to the base to make every face congruent to each other. So yesterday I asked you this question and some of you guys looked at me like I was bat crap crazy.
Guano.
So,
That's guano.
Okay, yeah, bat guano. Yeah, thanks. So look at this shape. This is a net, right? This is a net of a pyramid. Don't judge those. Compared to, say, a shape that was like, what if this was my base and these were my faces? Okay. So tell me, are these congruent to each other, these faces? Are all these triangles the same? No, they're not, because all of the sides are not the same. But are these triangles all the same? Yeah, they are. Pretend they are. Yeah, they are. Because why? Well, because all of the sides of the base are congruent. Do you know what it's called when all of the measurements are the same? What kind of polygon has all the measurements the same? The sides are the same, the angles are the same, all of it. It's called a regular polygon. A regular polygon. So what would make all of the triangular faces congruent to each other? If I had a regular polygon, like a square or a regular hexagon, just any shape as long as all the sides are congruent. So regular means that the sides are congruent, has congruent sides, and it has congruent interior angles. That's what regular means. Congruent sides, congruent interior angles. Okay. Question 4 talks about a cone. A cone is very similar to a pyramid, except that instead of having a polygon base, it has a circular base, right? Has a circular base. Okay. Like a cylinder, this curve is a circle, right? It's a circle. Our base is a circle. So it says that a cone, much like a cylinder, can be produced by rotating a common 2D shape around one of its sides. Any ideas? Yeah. What kind of a triangle? A right triangle. If I had a right triangle right here, and as I rotated it about, it would make a circular bottom, but this top piece it's not going to get any bigger. It just is going to spin. Okay, so this would be what kind of a triangle again? A right triangle. And it says to draw it. Zach, are you taking notes? Okay, so that's what it would look like. Pretend that's a beautiful right triangle. Okay. Question B says, describe the cross sections of the cone below. So this cross section right here, this cross section right here, how would you describe that? What would you say about this cross section? Yeah. What shape does it make? It's a circle. And it's, it's similar to the base. Aren't all circles similar to each other? Kind of?
Yeah.
Forever, right? All circles are similar. So it's a circle, and all circles are similar. They're not all congruent, but they're all similar. What kind of a shape does this next cross section create? I'm cutting it at a slant. We don't call it ovals, and we don't say the word oval in math. Shh. It's called an elongated circle. But you guys had math too, right? So I think that you guys don't you do quadratics and cubics? You do quadratic functions in math too. That's pretty much all, right? So you guys should have heard this word before. Yeah, have you guys heard that? An ellipse? Okay. So it's an elongated circle or an ellipse. That's really what it is. Okay. What about this next shape right here? If I were just to take my cylinder and just cut this chunk out, what shape does that make?
That's a semicircle.
It's not necessarily a semicircle because the radius here is much bigger than this, right? You don't have the same dimension. It's not a triangle. I'm going back to it. Hang on. It's not a TP either. Who said a TP? No, it's not a TP. What is this shape right here? What's that blue section? What kind of graph does that look like? It does look like an igloo. I think it's because I colored it blue. It's a what? It's a parabola. Yeah. This makes a parabolic shape or parabola-like parabolic shape. Okay. The last cross section, I cut directly through the apex and I went straight down. Directly through the apex and I went straight down. So what shape is this? It's a triangle. Yeah. It is a triangle. Okay. All right. So we have 35 minutes. This is a ton of time. So, yeah, I think you should start on your homework too. Tomorrow, I won't push you to do the next activity. We'll just wait till tomorrow. That's perfect. So I'm going to stop the video and I'm going to go back to the module.